How's it going, everyone? So the objective of this video is to walk through the final course project description document, which, as I mentioned, will also serve as the template. What that means is you're actually going to be filling in your answers directly on this document, and also just provide a broad overview of the level of expectations that I have for the project. I think when you see that you have a final course project in any course, and especially when it's the description of the project talks about it being an opportunity for you to go through the engineering design process, that your natural tendency is to think that the ask or your deliverable level is going to be pretty large, that it's going to take a lot of time and that you're going to have a lot to do. But that isn't really the case here. Really, all that I'm looking for you to do is to show some level of creativity and show me that you understand the process fundamentally that engineers do to walk through at least one stage of the design cycle. So even though if you have skills in either prototyping or in engineering graphics, and you want to show those off with respect to kind of tangible outputs of your design process, you're welcome to do so. However, that's not necessarily an expectation here. I think if you're working in a group, as long as you've been having initial interchanges with your group members about what project you're going to be working on, this is probably like an 1.5 to 2 hour type ask. So the first portion of the project description is just setting up the need, it's setting up the ask, and really it's detailing the economic shift that we're going to have associated with, and I shouldn't even say that we're going to have, that we're really having now with respect to changing demographics. And if you think about the cost structure of our healthcare system now and what a large financial burden that places on our economy, as a larger portion of individuals in the country are going to be consuming more medical services, of course, there's going to be not only, I wouldn't even say plenty of room for innovation, but kind of a demand for innovation. And engineers, of course, of various types are well equipped to add value in various different ways to attempt to address this problem. So I'm curious to see what kind of innovative solutions that you'll come up with, but that's really the intent there, is just to take kind of a vertical or a problem domain that, regardless of what type of engineering you're working on, that you can relate to. I'm sure that all of us have some experience with elderly individuals, and also that you could come up with some kind of innovation. It doesn't have to be hardware. It could be software. It could be a process, even with respect to queuing or routing people inside any kind of healthcare system. But step one, what I'd like you to do with your group is kind of to go through and kind of ask yourself all the different opportunities that exist to add value with respect to addressing this, what is known as the aging in place problem, or trying to minimize the amount of actual resources of healthcare that aging individuals consume. And the one thing that I definitely want you to do here is not just kind of form an idea based upon your own opinion. Of course, that's a good initial step in identifying a problem to address. However, I would also like you to kind of back up whatever problem you suggest with a citation. So I give you an example here of the 2 to 3 sentences that I would be looking for. I'm sure that many of you are aware that falls are an incredible issue in the healthcare system for elderly individuals. I have a citation there that they are the leading cause of injury and death amongst elderly people. But of course, there's a large financial component to that as well. And particularly falls amongst individuals that don't have anyone around them are going to be an additional concern. So just whatever opportunity you come up with there, and opportunity, I know you might say, is not a well-chosen word, given that we're talking about real difficulties in people's lives, but hopefully everyone knows what I mean by that. So it might be an opportunity to improve quality of life by causing them to adhere better to some type of best practice or protocol, maybe hydration, maybe nutrition, maybe pills. There's lots of stuff in that space, particularly with the technologies that attempt to ensure that someone is taking the medications that they're prescribed to take at scheduled intervals. So stage 2, what I'm really looking for you to do there is, based upon whatever problem you suggest in step 1 and whatever citation you provide, to propose some sort of engineering solution that can help address this problem. And again, I want to emphasize, it doesn't have to be a physical thing. It doesn't have to be hardware. It could be software. Ideally, I think what the majority of you tend to propose, I've used this project now for 2 semesters, is some sort of hardware and software integration solution. So kind of in that space of the Internet of Things or edge computing that we talked about earlier in the course. So what I'm looking for this portion of the actual project are 3 to 5 sentences that show me any way that anyone else approaches the problem now. And it could be one competitive solution is that no one is attempting to solve this problem. But probably if you do a little bit of digging, you will see that other people are attempting to solve it in some way. In addition, this 3 to 5 cents section should define what your solution is. And if you have competitors, it should show whatever your proposed value proposition is relative to those competitors. And I would like to see 1 or 2 references kind of supporting your claims here. So if you think about fall detection for elderly individuals, usually they come in 1 or 2 flavors. You ask people to, and again, I don't want to confuse anyone. Just because the reason I'm talking about fall detection here is that is the example that I picked for my opportunity in the example problem. And you're welcome to do fall detection, but if you do, please try to differentiate a little bit from what I did here. So again, going back to kind of the competitive solutions for fall detection, oftentimes people wear inertial sensors that can sense the type of accelerations associated with someone falling down. Or in addition, you can just put a bunch of cameras in the house. And of course, they're not going to necessarily prevent falling, but they may have a capability to detect falling. So who knows, maybe you want to address something related to preventing falling. And maybe you look around in the literature and you see that there are some cues that indicate when someone might fall. Maybe if you're tracking their nutrition or their hydration in scenarios when they're not consuming according to protocol and they have, I don't know, some level of shakes or vibrations with them, they're likely to fall. So you encourage someone to come check on them or encourage them to settle down. But the problem particularly that I'm dealing with here is fall detection, where you don't want someone to fall and then be on the ground and die because no one's there to help. So in terms of how people address that, you can use wearables or you can use cameras. Obviously, both of those have disadvantages. You put cameras in someone's house, it's privacy invasive. If you have them wear wearables, they have to remember to wear them. And even for younger individuals, that's an issue sometimes, not only of forgetting, but also of preference. So there you see the value proposition that we're talking about is we are going to provide more in terms of convenience and in terms of preserving privacy. And maybe we will choose to go to market and charge a higher price for this since we have a superior solution. And there's no right answer for this. But what I'm looking for is if you go back to that lecture that we talked about, the engineering design process, and I kind of showed the value proposition decomposition, where you talk about the value that you're providing to the customer. Are you providing the same or are you providing more? Along with the price point. Are you doing it less price? Are you doing it the same price? Or are you doing it more price? So whatever you have to create value. So you either have to do the same thing or more than current competitive technologies are doing. And you have to do that at some price point, either less, the same, or more, depending on how you want to go about kind of positioning your product in the market. So step 3, preliminary research or customer discovery. I'm looking again for just 4 to 6 sentences based upon whatever solution you proposed in step 2 that would allow you to initiate the design process. So this is just basically what you would do in order to start building or start designing. So here to initiate the design process, the first thing that I would do if I were going to be building this, and I think I particularly proposed an ultrasonic sensor here, an acoustic sensor which senses falls. Well, if I know the general principle of how that works, I'm basically going to send out a sound wave or an acoustic wave at some frequency people can't hear. So somewhere between like 15 kilohertz and 20 kilohertz, it's going to propagate in the environment. When it encounters a difference in acoustic impedance, there's going to be a reflection, and that reflection is going to be captured. And based upon timing information about when I send the pulse and when I receive the pulse, I'll be able to range how far away someone is. So that's just underlying physics. As engineers, we know that those sensors exist. However, I don't know like offhand what the part number is for the cheapest sensor available or how the performance of those sensors varies as a function of price. So the first thing I would need to do is look at existing, this is kind of getting to the supply chain portion of the actual design. But the first thing would be to just look at everything on the commercial market. Are there other kind of contactless privacy preserving sensors? Because you don't just have to do this with sound. You could do it with lasers as well. You could have a LiDAR-based approach. I would want to look at whatever you're doing, all of the different commercial products that are available. Look at online feedback, right? That's an easy way to get a large scale of customer information without having to manually go through and call people or ask people or so on. It's interesting at this Amazon training that I'm at right now. One of the things that every use case of artificial intelligence that they talk about largely reduces to natural language processing or processing text in order to mine customer reviews. Because, of course, for them, that's a huge thing. And they talk about how noisy that data is. So just an interesting relation to where I'm at now. But really, by looking at the online feedback for competitive products, that naturally gives you an opportunity to identify innovations within your design. In addition, of course, if you're going to put in the effort to go through an engineering design, particularly for a company, your company's paying you a lot of money, you are generating intellectual property, they're going to be interested in potential pathways to protect that, whether it's through patent or maybe even if they don't choose to pursue protection through a patent, they will want to know that they're not necessarily infringing on someone else's patent in order to avoid lawsuits. In addition, it's good to, even though you do broad kind of reviews of online sources of information and form your own opinions, it's always good to do what's known as customer discovery in terms of getting actual people in the room that have some stake in the problem. Maybe it's end users, maybe it's loved ones of end users, maybe it's clinical care providers, like people that are in the home healthcare type business, and trying to just see what they have to say. And of course, even though we are engineers, when you talk about going into manufacturing, usually you're either talking about a very niche subset of engineers that really know that space well, or really a combination of professionals in the supply chain kind of technology space that you really have to talk to in terms of ensuring that you have design for manufacturability. In a year or two, you'll be able to take everything that we're talking about once you've had some fundamental engineering courses and actually fabricate together a prototype, a minimum viable product, an MVP, using kind of rapid prototyping technologies. So we could, for this sensor, we could 3D print the case, and we could get a breadboard, and we could actually wire all of the individual sensor components and the computing together, and we could program the computing on an Arduino, and we could tap out some holes and drill it, secure it, blah, blah, blah. But the issue is that's not going to be a manufacturable product, particularly one that is optimized for profitability at scale. So you want to talk to people that if you're going to be proposing to actually fabricate a consumer product, you would want to include in your plan consulting with people that have expertise in that space of designing for manufacturability at scale. So step 4, conceptualization. What I'm looking for here is to actually talk about how you would prepare your final solution concept. So step 3, if you think about it, it's like, okay, here's a general idea of what we want to build. Here's how we're going to go out into the literature and how we're going to talk to people and try to refine our specific idea. Okay, now here's our actual first concept. So when you think about how you would express an engineering design, and this is something that we spoke of in the engineering design lecture, there's lots of different formats that you could use depending on what you're building. Obviously, if you're building hardware, the most fundamental and effective way to convey that is through some type of graphical solution. So maybe it's a hand sketch. Maybe you would build a CAD model. Ideally, in the modern environment, you would build a 3D model. You know, some different technologies that you could use in order to generate very realistic 3D models quickly through photogrammetry. That's one of the things that we've discussed. Maybe if it's going to be hardware that also has some other operating characteristics to it, you wouldn't only want a 3D model of its physical form factor and the way it looks, but you would also want some capability to simulate how it would actually perform. So maybe you'd form a whole digital twin of it, or so on. Maybe if it's a process or software, you'd have some kind of flow chart that just describes the logic behind how it works. Ideally, if you're building something that's hardware and software, maybe you would have both. In addition, kind of some brief bulleted descriptions of the intended functionality or the intended operation. These are the different modes that this is going to operate in. These are the different things that this is going to do, along with some kind of bill of materials. Oftentimes that's called a BOM. Ideally, you want to get as specific here as possible. Here's a particular part that I want to order. And if you want to get into the specifics of saying you're going to try to produce an initial batch of X, here's how many I would need. Or probably more likely, I would need this many of these components for each unit of my product that I'm producing, along with any lessons that you learned from your research. So here is an actual example of what you could have for the output of stage 4 conceptualization. I have a basic drawing that conveys some just key functional aspects, and it's very basic, of the product in terms of its physical form factor. This isn't a photorealistic product because most people, I should be careful how I say this, they will care how it looks, but particularly in the aging in place market, right, it might not be as big of an actual deal here. So I do describe some of how the aesthetic features could be chosen through a prototyping stage. But I have some descriptive text here in addition to conveying the form factor about which of each of those components are. So really, that's however deep you want to dive into it. Again, the goal is not to teach you in this project how to form a bill of materials. It's not how to do engineering drawing. That's out of the scope of this course. But it's to kind of show you how the actual process works and guide you through one stage of the iteration. So step 5 is really the most important. After you've kind of looked at the problem that you're trying to solve, the aging in place problem, you've proposed a solution and you've differentiated it and formed a value proposition relative to competitors. You've talked about how you'll do initial research in order to begin your design process. You've came up with one concept. And step 4, the next thing that you're going to want to do is basically accelerate your failure cycle. Grab a little bit of data. That way you can actually improve your design in subsequent iterations. And the way that we do that, of course, is to have some sort of prototype. And remember back to the discussion board assignment that we did on the AED, prototypes don't necessarily have to be completely functional. They don't have to do everything that the end product is going to do. So for example, for this acoustic sensor that I'm proposing to build, since one of the reasons that someone is going to buy it is based upon how it looks, I could build a version that doesn't work at all. And I could take that into user testing and I could ask individuals, hey, which A/B testing, right? Would you prefer to buy one that has this color and kind of this finishing, or one that has this color and this finishing? I can kind of optimize for my target audience certain functional attributes of my product or aesthetic attributes of my product without having a prototype that's completely functional. So here, all that I'm looking for is what kind of prototype would you build? What design features would you be intending to test with your prototype? And how would you do it through focus groups? And here's an example of the 2 to 4 sentences that you're turning in for that. So again, all that you're doing here is basically wherever you see italic text, when I grade your actual submission, I'll be looking for you to have replicant text there. So 2 sentences here with a citation. For step 2, we have 3 to 5 sentences here with some citations. For step 3, we have 4 to 6 sentences, and step 4, some text along with some sort of additional graphics, maybe just a cheap hand sketch showing me the basic concept. Maybe it's a flow chart, maybe it's some bulleted kind of functionality list or so on. And then a plan of how you would take identified key attributes of your product that could be tested by some preliminary prototyping and user testing, how you would do it. And don't forget to actually close the feedback loop there, right? In addition to telling me what features your prototype would have that you would intend to test, what target audience you would be using in order to test it, and how you would be getting that data, how you would take that data and subsequently improve the next prototype of your product. And ideally, of course, as we discussed in the actual design lecture, what happens is as you're improving certain features of the product through subsequent design iterations, you're also adding more functionality to your prototype, such that when you're on V4, V5, V6 of a prototype, certain features have been optimized, maybe the low-cost, cheap ones at first, like the aesthetic ones and so on. And by the time you're ready to go into final stage user testing, you have something that's completely functional that you can maybe deploy for not necessarily the A/B type testing that we talked about, where you get people in the room and you say, hey, do you like this or do you like this? Now you actually give it to them and say, hey, live for this with a week and tell me all of your pain points. Tell me if it improved your quality of life. And then you can kind of start to build that you have a fully functional prototype. Hey, is this something that you would buy? If it is, how much would you pay for it? And so on. So getting into a little bit of the kind of marketing function of maturing it past the actual design stage. Because of course, once you have a fully formed prototype, you have to take it to manufacturability. That's where you're going to have to make trade-offs associated with the cost of production, both in terms of the bill of materials, along with the manufacturing processes, quality levels, and so on. And in order to kind of understand how you can operate in that trade-off space of cost, you have to have some idea of anticipated revenue. That way you can ensure profitability. So hopefully that provided a good overview of how the engineering design process works, going from ideation, kind of coming up with an idea to address a problem, differentiation in product design, what are you going to do that other people aren't doing in terms of addressing that problem, and how you actually go through conceptualization and plan some type of prototyping and initial user testing in order to shorten that feedback loop in the design cycle, which is really where the innovation comes through. No one designs perfect on the first try. It's really how much can you improve each cycle and how short can you make the cycles such that in a fixed amount of time, you can have the maximum amount of improvement or innovation possible. So please feel free to reach out with any questions, and I'll talk to you all soon.